Hello all, so today in this video we'll be seeing about three types of elastic constants, and we will solve some numerical problems related to the elastic constants. First of all, we will see what are the three elastic constants. So we have the first one, which is Young's modulus. So Young's modulus is basically the ratio of either compressive stress to compressive strain or tensile stress to tensile strain. It is denoted by the symbol capital E, and the units of Young's modulus will be the units of stress, because strain doesn't have any unit. And next comes is rigidity modulus. So rigidity modulus is defined as the ratio of shear stress to shear strain, and we denote rigidity modulus by the symbol either C or N or G. So I'll be using C here, and this is also called as shear modulus. So shear modulus is given by the formula tau by shear strain, which is gamma or delta, however you call it. Next comes bulk modulus. So bulk modulus is the ratio of normal stress to volumetric strain. So it's sigma n by EV. And last comes Poisson's ratio. Poisson's ratio is not an elastic constant, but Poisson ratio has a relationship between uh, with the other three elastic constants. So basically, Poisson's ratio is the ratio between lateral strain of a body to the longitudinal strain. So when you take any bar element or any rod and you apply a pulling force, so when there is a change in the elongation, when there is a change in length, automatically the transverse direction will get reduced, like diameter. When length is changing, diameter will reduce. So that diameter coming down or the thickness coming down is only a lateral strain. So the ratio of lateral strain to longitudinal strain is called as Poisson's ratio. We denote Poisson's ratio by the symbol mu, or 1 by m. And mu for some important materials like concrete is in between 0.1 to 0.2. For mild steel is 0.303, and for stainless steel is 0.305, and for cork it is 0. So this is the relationship between three elastic constants. So you can see E is equal to 2c into 1 plus mu. So if somebody wants to know what is the value of E when C is given, then we have to use this relationship, which is E is equal to 2c into 1 plus mu. And similarly, if somebody knows the value of K and they want to calculate the value of E, then we can use the relationship E is equal to 3k into 1 minus 2 mu. And we have another relation, which is E equal to 9kc by 3k plus c. This is the relationship between E and the other two elastic constants. So here we have relationship between E and C. In the second one we have relationship between E and K, and third relation is in between E, K and C. So wherever useful, we will apply the relevant formula and calculate the other unknown value. Okay, now quickly we'll calculate a numerical problem related to the elastic constant. So you can see for a material, Young's modulus is given as 1.4 into 10 power 5 Newton per mm square. Poisson's ratio is 0.28. Find bulk modulus. So what is given to us? So the data given to us is that Young's modulus is given, which is E is equal to 1.4 into 10 power 5 Newton per mm square. And Poisson's ratio mu is given to us, which is 0.28. He is asking us to calculate the value of bulk modulus K. So now we have a relationship, as I've told here. We will take this help of this relationship. So you can see here, I'll take the relationship of E is equal to 3k into 1 minus 2 mu, because I have the value of E and I have the value of mu. So from the relationship, E is equal to 3k into 1 minus 2 mu. I will write k as E by 3 into 1 minus 2 mu. So from here, k is equal to, what is the value of E? 1.4 into 10 power 5 by 3 into 1 minus 2 into 0.28. So if you solve this, our k value will come approximately 1.06 into 10 power 5 Newton per mm square. So this is a basic level model problem. So this is how, if you know a relationship, you can calculate the other unknown. Let's move to the next problem. So a bar of 20 mm diameter is subjected to a pull of 50 kilonewton. The measured extension on gauge length of 250 mm is 0.12 mm and change in diameter is 0.00375 mm. Calculate Young's modulus, Poisson's ratio and bulk modulus. Okay. So first let's see what is the given data. So what is given to us initially? Diameter is given. So D is equal to 20 mm. Okay, and pull is given. So capital P is equal to 50 kilonewton, which is equal to 50 into 10 power 3 Newton. Okay, and he's telling The measured extension on gauge length means capital L is 250 mm, and the extension on this 250 mm because of the pull is equal to how much? Delta L, which is equal to 0.12 mm, and change in diameter is given, which is delta D, which is equal to 0.00375 mm. He is asking us to calculate the values of Young's modulus, which is capital E, and Poisson's ratio mu and K value. So we want the values of E, and we want the value of mu, and we want the value of K. So let's see how we can solve this. So first, initially we will start calculating the value of Young's modulus first. Okay, so first we will calculate the value of Young's modulus. Okay, so I'm giving the heading Young's modulus. So we all know what is the formula for Young's modulus. Young's modulus, capital E, is equal to stress by strain. Here strain means it is longitudinal strain. So if you know the value of sigma and E, you can get the value of E. So first let's calculate stress. What is stress? Load by area. So what is the load given here? 50 into 10 power 3 by area is pi by 4 of 20 square. Okay, so I can write this as 50 into 10 power 3 into 4 by pi into 20 square. So from here stress value comes out to be approximately 159.15 Newton per mm square. Once I got the value of stress, I'll calculate strain, which is the longitudinal strain. Longitudinal strain is equal to change in length by original length, so which is equal to 0.12 by 250. So this E value comes out to be around 4.8 into 10 power minus 4, and strain doesn't have any unit. Now let's calculate the value of E. E is equal to sigma by E, correct? So which is equal to 159.15 by 4.8 into 10 power minus 4. So the answer for Young's modulus comes out to be around um, 33.15 into 10 power 4. 33.15 into 10 power 4 Newton per mm square are the units. So this is how you can calculate the value of Young's modulus. Now with the value of Young's modulus, we will calculate Poisson's ratio and bulk modulus. Okay. Now we will see how to calculate Poisson's ratio. So second heading is Poisson's ratio. So Poisson's ratio, how do you calculate the value of Poisson's ratio? First of all, definition of Poisson's ratio, just now we discussed, it is lateral strain by longitudinal strain. So it is E lateral by E longitudinal. E longitudinal we already have. We will calculate E lateral first. So E lateral is nothing but delta D by D. It is change in diameter by original diameter. So once you do this value of what you call E lateral, then you can substitute this E lateral value in the above equation. Okay, so it is 0.00375 by, what is the value of original diameter? It was 20. So you get E lateral value to be around how much is 1.875 into 10 power minus 4. So now we will calculate the value of mu. Mu is equal to 1.875 into 10 power minus 4 by, what is longitudinal strain? Longitudinal strain is how much we got here? 4.8 into 10 power minus 4. So 4.8 into 10 power minus 4, this both will get cancelled. So our E value, mu value comes out to be around 0.39. This is how you have to calculate the value for Poisson's ratio. And finally, we are remaining with one calculation, which is bulk modulus. Just as in the previous problem, we used the relationship, the same relationship we will use. So now we will calculate the value of bulk modulus. So bulk modulus is given by K. Just now we have seen the relationship in the earlier problem also. So we know that capital E is equal to 3K into 1 minus 2 mu. So from here we can write K is equal to E by 3 into 1 minus 2 mu. So we have the value of E, we have the value of mu. What is the value of E? We got 33.15 into 10 power 4. 33.15 into 10 power 4 divided by 3 into 1 minus 2 into 0.39. So this value comes out to be approximately equal to 50.22 into 10 power 4 Newton per mm square. So this is how you need to calculate the value of K. Okay, so this is one model of problem where we calculate Young's modulus followed by Poisson's ratio and bulk modulus. So next we will see another model of problem. So see here, a bar 30 mm in diameter is subjected to a tensile load of 54 kilonewton and measured extension on 300 mm gauge length was 0.112 mm and change in diameter was 0.00366 mm. Calculate Poisson's ratio and also the value of three elastic constants. So this problem is little similar to the earlier problem we have done, but here he is asking us to calculate the value of three constants. Okay, so first we will start off with the given data again. So it's always preferable to write the given data so that if you know what is given, you know what is asked, then you can find out the relation between them. So here you can see diameter D is 30 mm and tensile load P is equal to how much? It is 54 kilonewton, so which is equal to 54 into 10 power 3 newton, and then we have gauge length L is equal to 300 mm and extension on this gauge length is 0.112 mm, and then we have change in dia is equal to 0.00366 mm. Okay, now he is asking us to calculate the value of Poisson's ratio as well as the three elastic constants. So first we will calculate Poisson's ratio. So our first heading is calculation of Poisson's ratio. So how do we calculate the Poisson's ratio? Just now we discussed the formula, right? Poisson's ratio is lateral strain by longitudinal strain. So Poisson's ratio is my heading. So we have mu is equal to E lateral by E longitudinal. So initially, what is E lateral? Change in dia by original dia. E longitudinal is change in length by original length. So we will do here E lateral is equal to delta D by D. So what is delta D? 0.00366 by what is D? 30. So our E lateral comes out to be 1.22 into 10 power minus 4. Next comes E longitudinal. E longitudinal is given by the formula change in length by original length. So it is 0.112 by what is the original length? 300. So our E long comes out to be around 3.73 into 10 power minus 4. Now mu. What is mu equal to? E lateral by E longitudinal. So it's 1.22 into 10 power minus 4 divided by 3.73 into 10 power minus 4. So from here 10 power minus 4, 10 power minus 4 will get cancelled. So our mu value comes out to be around 0.327. This is how you need to calculate the value for Poisson's ratio. Now we will start calculating the values of three elastic constants. So means we have to calculate the value of E, C and K. So first let's start calculating the value of E, okay, which is the Young's modulus. So we know that Young's modulus is equal to stress by strain, correct? So we know that here strain means longitudinal strain. What is stress equal to? Load by area. So it is 54 into 10 power 3 by what is area? Pi by 4 of what was the dia? We had 30. Pi by 4 of 30 square divided by what is E longitudinal we got just now? 3.73 into 10 power minus 4. So finally from here Young's modulus can be written as 54 into 10 power 3 into 4 by 30 square into 3.73 into 10 power minus 4. So from here our Young's modulus will come out to be 20.48 into 10 power 4 Newton per mm square. This is the value for elastic modulus. Now what is the second value we need to calculate? We need to calculate the value for what uh, bulk modulus we will calculate, because we know the relationship between E and K now. So we'll calculate bulk modulus, then we will calculate C. So again same formula, E is equal to 3K into 1 minus 2 mu. The same formula we will take. So from here K is equal to E by 3 into 1 minus 2 mu. So I will continue here. So K is equal to what is the value of E? 20.48 into 10 power 4 by this is 3 into 1 minus 2 into what was our Poisson's ratio? 0.327. So into 0.327 if you put it, so you will get the K value is equal to approximately 19.73 into 10 power 4 Newton per mm square. This is 4, okay. So this is how you get the value for bulk modulus. And finally comes the third one, which is your shear modulus, that is C. So for calculating shear modulus, you can take any relationship. You can use the third relationship also. E is equal to 9kc by 3k plus c you can use, but let's not make it complicated. So I will take this relationship. E is equal to 2c into 1 plus mu, so that I'll get C easily. So we'll come back to our problem. Yeah, so we will take the relationship of E is equal to 2c into 1 plus mu. So from here I can write C is equal to E by 2 into 1 plus mu. So from here C is equal to, what is the value of E? 20.48 into 10 power 4 by 2 into 1 plus, what is mu value? 0.327. So if I solve this, I will get the value of C around 7.71 into 10 power 4 Newton per mm square. So maybe little variation in the decimal can take place because it depends on how we are substituting 2 decimals or 3 decimals. So like this we have to solve problems related to Young's modulus. So one has to remember about the definitions, and then you have to solve problems related to uh, the elastic constants. So I hope all of you understood the video. Thanks for watching.